Hey guys, chapter 7, section 5 video here for you. We're working on how can I write a proportion. So we're going to work on writing proportions for situations. Now here's something we know. A proportion, which I'm going to draw an arrow to, is two equal ratios. So if you have two equal fractions, you have a proportion. And we've definitely worked on graphing proportions, looking at it in a table, but now we're going to start talking about situations. So we're going to try a problem here. Example 1. Here's a very typical proportional problem. A tree in the forest casts a 43-foot long shadow. A 4.5-foot kid casts a 10-foot shadow at the same time. How tall is the tree? Okay, so imagine that you have a tree and a boy that are both standing out in the woods and the sun is beating down on them and they both have a shadow. Well, the tree is tall and big and has a big 43-foot shadow. But the boy's not that tall, he's a kid. He's got a 10-foot shadow. But knowing that information, we can solve for how tall that tree is without having to actually climb the tree and measure it. That would be a lot of work. We're going to do it without climbing the tree. So here's what we're going to do. We're going to break this problem into 3 steps. Step 1, Step 2, Step 3. The first step is I like to draw a picture of the situation. So we're going to draw a picture, then we're going to make a table, and then we're going to write an equation. So that'll be our plan. Let's start with the picture first. So what do we got? We got a tree and a boy. So I'm going to draw a line that represents the ground. So there's the dirt in the forest, the ground. Here's my tree, so go ahead and draw your best looking tree. And here's my boy. And if you want, you can just draw a little stick figure kid. And both of them are casting a shadow from the sun. So here's my sun. So as the sun beats down on them, a shadow casts off the tree and a shadow casts off the boy. And the shadow, I'm going to shade in gray down at the bottom. The tree has a long shadow. It's 43 feet. But the boy casts a smaller shadow that's only 10 feet. So here is our picture. I hope you have a decent looking picture in your notebook also, showing the shadow and showing the boy in the tree. Now, here's the next thing we know. The boy, we know how tall he is, but the tree we do not. The boy is 4.5 feet tall. I'm going to write 4.5 feet tall. But the tree, I'm going to put a question mark on. I do not know how tall the tree is. But that's okay. We have enough information now. We can solve for that. So now that we got our picture, let's build a table. The table's going to have 2 things. It's going to be more like a T-chart. It's going to have the height and it's going to have the shadow length, both being measured in feet. So we've got 2 things here. We got the boy and the tree. We know the boy's height is 4.5 feet, and we know his shadow is 10 feet. The tree, though, we don't know its height, so that's our x. That's our variable that we don't know, but we know its shadow is 43. We can totally solve for x. We're going to take this table here and turn it into step 3, an equation. Here is the equation. We're going to set up 2 equal fractions. X over 43 would be the tree. That's how tall it is and its shadow. And then for the boy, it'd be 4.5 over 10. That's how tall he is and his shadow. Now we're going to put an easy line down the middle, solve for x, and do something we already know how to do. So let's solve for x. Let's get it all by itself here. Let's see. Cross multiply would be a strategy. We could do 10 times x and 43 times 4.5. So that'd be 10x and 193.5. And then we just got to divide that 10 away. So divide by 10, and we get 19.35, which is our answer to how tall is the tree. It is 19.35 feet tall, almost 20 feet tall. That's our solution. In fact, I'm going to go back to my picture now, take that question mark away, and put 19.35 feet. That's the height of the tree. Cool. All right, we solved it. So let me show you a new problem here. You guys ever get photos printed? Like, do you ever go to Costco or Shopko or Walmart or something and print your pictures? Well, if you do, when you go to print your pictures, you can choose the size that you want. You can get a really small picture or you can enlarge it really big. And there's something about that I want to show you. Here's a picture of Russell Wilson, one of my all-time favorite football players. And I'm going to show you something here. I'm going to switch out of my Keynote. Okay, so I just found a picture of Russell Wilson online, just a Google search, and I pasted it into a Word document here. And I wanted to show you something over here on the side. If I click on his picture, if you look over on the right-hand side, there's this little tiny checkbox that says Constrain Proportions. Look at that word proportions, it's right in here. What this means is if the box is checked, I can click on Russell Wilson's picture and I can enlarge it and I can shrink it. And when I'm shrinking it, notice he still looks the exact same in that picture. He hasn't changed how he looked. He's just really tiny. And when I enlarge it, he just gets really, really, really big. But the picture doesn't change. It's still the same picture. But if I click this box, Constrain Proportions, and I turn the proportions off, now there are no more proportions. Watch what happens when I start moving his picture around now. Oh, he's got all squished. He's getting warped. He looks weird. So he starts getting kind of weird looking. See how that happens? Well, that's because I'm not shrinking and enlarging him with proportions. If it's not with a proportion, then it gets weird looking. So you have to use proportions. It means when I shrink it, I gotta shrink the length and the width at the same rate. That way his face doesn't look weird when I start shrinking him or enlarging him. But if I turn off the proportions and I start messing with his picture, he gets all warped and weird looking and it doesn't make sense. Okay, so why am I showing you this? Because we are going to do a problem about enlarging a picture. So example 2, we're going to go in 3 steps. There's going to be a picture, a table, and an equation for this. We're going to start with the picture first. Here's the situation. You have a photo and you're going to take it to the store. And your plan is to enlarge it and blow it up and make it big, maybe almost like a poster or something. Now, your photo that you want enlarged, you're expecting it to be 12.5 inches wide and 20 inches long. That's the size of the picture that you want. So you go to the store and you say, I need a picture, I want it enlarged, and this is how big I want it. Well, the original photo was 5 inches wide, and we don't know how long the original photo was. It was X long. That's the part we don't know. Okay. We're going to solve for x by making a table and an equation. Here's what's going to go into our table. It's going to look like a T-chart. It's going to have 2 things. It's going to have the length of the picture and the width of the picture. And there's 2 pictures. There's the photo and the enlargement. So the original photo and the enlargement. So the original photo is 5 inches long, but X inches wide. And the enlargement is 12.5 inches long and 20 inches wide. And our job is to solve for x. So we're going to take this table and build it into an equation. We're going to put 5 over x, that's the photo, so that's the length and the width, and we're going to put 12.5 over 20, and that's the enlargement length and width. Notice length and length are both on top of the fraction I decided to do, and width are both on the bottom. And we put a line down the middle, and we solve for x. We use the skills we already have. So again, I'm going to cross multiply 20 times 5 and x times 12.5. That'd be 100 equals 12.5x. And then what do I do to get rid of the 12.5? Oh yeah, I divide it. So divide it away, grab a calculator, type in 100 divided by 12.5. Always double check my math. I make mistakes in these videos sometimes, so always be double checking me so you can tell me in class if I make a mistake. Oh, here it is. X is equal to 8. I hope that's what you got. So that's going to be inches wide for our solution, 8 inches wide. And if we go back to our picture, that means the photo is 8 inches across the bottom. That's our width. Awesome. Okay, so ending this video, I just want you to really take away that when you have these story problems, it's nice to draw a visual picture. I know you don't have to have the best drawing, like your tree and your little stick figure boy could be totally messy. But if you sketch it out, then you kind of understand the situation better. And then make a table and write an equation so you can solve this thing. That is our strategy. All right, thanks for watching, guys. There's going to be more on this later.